Okay, the next one I'll go ahead and show you algebraically or by Desmos. Algebraically, you need to get a common denominator on this side here. So you see how this has a 5x. You can't find anything that goes into 5 and 3 other than 1. So that means this second denominator will need a 5x. And of course, if I put a 5x on the bottom, I'm going to have to put a 5x on top as well. And then since this has a 3, once again, 3 doesn't go into 5, so I need a 3 top and bottom. So that's going to give me a 6 on top plus 5x. And my common denominator would be 3 times 5x, or 15x, is equal to 4 over 15x. Now, I could go ahead and cross multiply here, but here's one trick I want to show you. If you end up with fractions that are equal and the denominators are equal, it is true that the numerators are equal. You could cross multiply and multiply both sides by 15x, but all you're doing is making it harder than it needs to, because if the fractions are equal and the denominators are equal, the numerators are equal too. So I can just take, for my equation, a 5x, or a 6 plus 5x is 4. And then I can subtract 6 from both sides. So 5x equals -2. After I subtract 6 from both sides, that's gone. Then divide both sides by 5. So x equals -2/5. And if you were to graph that in Desmos like we did the last one, you'd have a more interesting graph, but it would cross at -0.4, which would be 2/5. For this one, I could solve it algebraically. If I wanted to, I would have to subtract on this side, so I would need to get a common denominator, starting by writing the -3 as a 3 over 1. The x has an understood 1 in front of it. So, really, you don't have to do anything to get a common denominator on the first one. On this other one, though, I do need to put an x on the bottom, since the first fraction has an x, and that will be an x top and bottom there. So that gives me a 1 minus 3x over x on this side, and the other side is still a 4x over x plus 2. Now at this point, I need to cross multiply, so that is a 1 minus 3x times x plus 2 over x times 4x. And honestly, doing this one algebraically, you're getting some interesting algebra here. I'm going to go over to the side to continue this on where I'll have a little bit more room. I need to multiply the 1 times the x, so that's an x. I multiply the 1 times the 2, which is a 2. Okay, now I take my minus 3x and multiply minus 3x times the first thing, which is x, so minus 3x squared. And then minus 3x times 2 is minus 6x. And then that's going to be equal to x times 4x is 4x squared. Now at this point, I have a true quadratic equation because I do not have the ability to combine to get rid of those x squareds. So since I can't get rid of the x squareds, I basically need to move everything to the same side of the equation. So what I'm going to choose to do is add this 3x squared to both sides. So that's going to give me a 7x squared. Then I'm going to add the 6x and subtract the x. So that's going to give me a 5x. And then I'm going to have to subtract the 2 to get it over there. So I end up with that for a quadratic equation. Now at this point, I might end up having to resort and solve that quadratic equation by graphing anyway, because that's a relatively difficult one to deal with. So I'm going to just show you how you can use graphing either of the quadratic or of the rational and how it gets you the same result. So if I go to Desmos and I graph that quadratic, here's what I have. So I have a solution of -1 and 0.286. That means if I were trying to factor it, that -1 would have given me a factor of x minus 1. And then the other decimal I had there of the 0.286, I would have x. Sorry, that should be an x plus 1 because it was a -1 and x minus 0.286. It's going to turn out that this I could multiply by 7, and that would have given me a 7x minus 1. Multiplying by 7 would have basically gotten rid of my decimal there. So in this case, you would have a -1 and a 1/7 would be your exact solutions. If you graph the rational graph, you would have gotten the same decimals. It would have been harder to figure out, though, that that decimal was 1/7.